Hi everyone. In this short video, we are going to learn what is a piecewise defined function. So this is part of what we have learned before about parent function. So piecewise defined function is a function that is defined using different equations on different parts of its domain. So what we have learned before, in all value of x in the domain, the equation define all value of x. However, in piecewise defined, the domain are separated into several parts, and each part will get different equation to define it. That's why it is said that this function is called piecewise defined, because it is defined piece by piece, like part by part. And now let's try to look at an example. So here we have fx is divided into three pieces or three parts of domain. So the first domain is from -3 to 1, and the second domain is x equal 1, and the last one is x greater than 1. So we're going to sketch the graph of this equation, of this function, So we can move to the first domain first. We see that it's going to be, I'm going to put the Cartesian plane first. Here you go. So now I'm going to do the first part of the domain with red pen. So we have -3. So we have our domain start from our first part of the domain, start from -3 until 1. Okay, but be careful here, it's 1 actually is not included. So we can like make in kind of line over there, because we have this equation. So let's make, for the first part, let's try to make, we plot the points. So x will be, let's say, from starting from -3, -2, let's say we can jump to 0 and 1. Okay, now the y will be, for -3, we have -2 times -3 plus 1, which is 7. And we also have 5 over here, and we have 1, and then we have -1. However, be careful, in this part, it is not included in the first domain, first part of the domain. Okay, so I'm going to plot the points. So we have 1, 2, 3, 4, 5, 6, let's say 7 over here. Here's our point, and -2 to 5, 0 to 1, and 1 to -1. Be careful because it's not included. Let's put a hole over there. So it's a dot, but it's not full dot, because we know it's a line. We can draw, like connect it with a straight line. Okay, now I'm going to do the second part. So x equal 1. When x equal 1, so fx or y equal 2. So this is actually just one point, just 1, 2. So let's put it on our plane. So this is our purple points over there. Now let me change the color. So let's go with green. Now when x greater than 1, so you will have, it's going to be x squared. So we can make another floating points, and let's say we start with 1 and 2 and so on, because it's the y is x squared, so it's actually our parent function. It's going to be 1, 4, and 9. But again, be careful, 1 is not included in the third part of the domain, so we cannot make it into a full dot. So let's create, so 1 with 1, it's going to be somewhere here, and 1 with 4, sorry, 2 with 4, 2, 4, and 3 with 9. Let's make it up there. Okay, so we know it's a curve, it's kind of curve. We can make it something like this. Okay, so our graph is quite unique. So this whole graph is actually the graph of fx. So it looks like cut here and there, so it's not smooth, but this is the graph of the function. And beware that this green curve will goes to infinity, because it's like the x is greater than 1, which means any value of x greater than 1. But for the red one, it started with -3, so the domain will be only like this yellow part. So any value less than -3 is not included in our function. It's not the domain of our function. Okay, so this is a piecewise defined function. If you encounter another example of piecewise defined function, what you need to remember is try to sketch the graph by doing it piece by piece or part by part of the domain.